Hey Thinksters, and welcome to Python one-liner trick number 6, I guess. It should be 6. So this is my Python one-liner series, as you may already know. So I want to give you your Python one-liner superpower with this video series, and this is part of my launch process of my new book, Python One-Liners, which I published with No Starch Press in 2020. So I'm really excited today because I have something special for you. I just got an email from one of my Python freelancer course members. So by the way, if you want to become a Python freelancer, earn money while you learn to code, then check out my free webinar. I have a link in the video description below. It's also great, and also in the Python one-liners book, I think I have a link. So the webinar is free, and you can see my journey from starting out as a self-employed Python freelancer to leading quite successful online business, Thinkster.com, which is fun. I enjoy working every day, so it's really great working from home and coding from home. I have a lot of time for my kids and for my family and my friends, and I don't care working from home because it's my. So these days with Corona and everything going on, everyone works from home somehow. But I have already worked from home for a few months now, so actually for maybe 2 years, and I enjoy it a lot. So there's no commute time, no stress. It's really it's healthy. I can do a lot of sports and going outside, walking and so on, and running, and it's the good life. So if you want to become a Python freelancer, then check out the Thinkster Python freelancer course and the free webinar, for which I have a link below in the description. Good. Okay, so what was it that my Thinkster user sent me? So I liked it. He used Turtle, and maybe you don't know Turtle, and this is actually not the topic of the video. I'm going completely off topic now. He used the framework Turtle, and this is for drawing stuff with Python. Yeah, so you have so he defines some colors, and then he goes over. So he iterates over actually 80 data points, defined here, size 80. It's not nicely written code, I have to admit, with this. So in one line he puts 2 statements and so on, so it's not nicely written, but it works. And what he does is then doing some math magic to visualize the Chris@Thinkster, which is my email address, text in a very nice way. So let's execute this to see what it does. Okay, so I have to. Okay, now you haven't seen it, right? Okay, the screen is too small. Yeah, but it visualizes this like in these 2 spirals. It visualizes Chris@Thinkster.com. So very nicely done, and you can do it easily with Python. So just import the Turtle framework, and this allows you to draw some basic stuff. You can implement some fun games, and it's a nice framework to work with. Okay, so let's go into today's Python one-liner. So imagine you are working at a small internet startup that keeps track of its users' web browsers, like for example Google. So what is the web browser of the user? Is it Chrome? Is it Safari, Firefox? And you store this data in a database to analyze it later. And then you load the gathered browser data into a large list of strings to analyze it. And but because there was a bug in your tracking algorithm, every second string is corrupted and needs to be replaced by the correct string. Okay, so some random scenario could happen in a practical setting. So let's remove this nice Turtle code, and I show you the data we have for our one-liner. And okay, so you see we have like browser data: Firefox corrupted, Chrome corrupted, Safari corrupted. So every second data entry is corrupted. And now assume that your web server always redirects the first web request of a user to another URL. So this is common practice in web development. For example, it's known under the HTML code 301, moved permanently. So you conclude that the first browser value, like this one, Firefox, will be equal to the second one in most cases. Of course, there will be some outliers and some exceptions, but in most cases, the first one will be equal to the second one, because usually you have this redirect in place. So therefore, you conclude that you can easily reproduce the original list by doing what? Yeah, by replacing this corrupted string with a string immediately in front of our second string. So this is our problem. We want to replace all. So in one line of code, very concisely, we want to replace. So of course, a professional coder would do this, would solve this problem in a few seconds. But yeah, we just take time to understand everything, the problem correctly. So we want to actually replace all corrupted strings with the string immediately in front of them in the list. Okay, so like this should become Firefox. This should become Chrome, and so on. Okay, so how do we do this? Of course, I mean, if you have multiple lines of code, you can do something like this for say I in range length from visitors. So I'm doing this yeah, so very quickly now. So you could do visitors I should equal to visitors I minus 1 if, maybe let's make this as so if I modulo 2 equals 1. So this means that we have an odd value here. So for example, the index 1, index 3, index 5, index 7, and so on. So only those will be considered. Index 4, 2, and 6, and so on will not be considered because they are not odd. So and we use the modulo operator to accomplish this. And now we set visitors I should be like overwritten to visitors I minus 1. And now we do this. So we go over the whole loop and we print the visitors list. So this would obviously solve the problem, right? We have Firefox, Chrome, Safari, and so on. So this nicely solves the problem, and it's also kind of readable, but it takes 3 lines of code and you have to think a bit. And as it turns out, in Python, there's a very concise one-liner that does exactly the same thing. So let's comment this whole thing out. How can we achieve the same thing in a single line of code? Yeah, so the answer is simple. We use slice assignment. So you already know about slicing. If you have watched the other videos in my Python one-liner series, then you know about slicing because I have already used it 1 or 2 times. And usually you can use slicing, for example, to print, like here, visitors. You can access some subsequence of the slice. You define a start index, say 1, stop index, say 5, and then you also have a step size, say every other element. Okay, so you can do something like this. We start with index 1, which is this one. We end with index 5 excluded. So our last element, so this would be index 5, but this is excluded, so this would be our end, the last value in our slice. So starting from here, this corrupted, going all the way to the right, and then also this including the Safari element, but then taking only every other element. So we have this one because we have step size 2. Okay, so we have that corrupted. So this should return corrupted. Okay, if you execute this, it gives us a list with 2 times corrupted. Okay, so this is how you can use slicing to access some values from the list. Okay, but now we want to override some values from the list and access some values from the list at the same time. How can we do this? Yeah, we can use a one-liner. So we use slice assignment. So slice assignment assigns. I just write this and then I will explain it in a moment. Okay, so slice assignment, you see now we have slicing on the right side of the equation. This you already know. This simply selects a substring. And what does it do? It takes the default and start and stop indices. So it goes over the whole indices. So it goes over the whole list, but it takes only every second element. So it starts here, Firefox, Chrome, Safari, Chrome, Firefox. So this is selected on the right-hand side of the equation. But now, and this is new, you use slicing at the left-hand side of the equation. What does it mean? It means that you select these values. The slice basically you select on the left-hand side, and you override them with the values of the on the right-hand side. Okay, so you override only a subsequence of the values on the left with the values on the right. Okay, so and what do you do here? Now you start with the index 1. Index 1 is here, this corrupted, and then you take every other element. So basically you select all corrupted strings in your original list, and you override them with your correct browser names. Okay, so in this very concise, this single line of code, it's much more readable, and I guess it's even faster because you don't have to do if checking and so on. You don't have to iterate a lot. So slicing is implemented very efficiently in C, Python, so in the C++ Python code base. So slicing is one of the fastest way of iterating over lists. So, and you can do slicing on the left and slicing on the right. If you do it on the left, it is called slice assignment, okay? And this way you override all values, all corrupted values with the browser data here, basically. Okay, so let's execute this. You see it's, okay, we still have selected this one. So now let's print the whole visitors list. Okay, you see now we have Firefox, Chrome, Safari, Chrome, Firefox. So everything as expected. So we have managed to get exactly the same output in a more efficient and more concise and more readable way by means of a Python one-liner. And this is why I love Python one-liners. Yeah, because it's not only is it more concise and more readable, but it's also faster in many cases. Okay, so in this case, it's a no-brainer to use Python one-liners. Sometimes, of course, you can discuss, do I have to write the quicksort algorithm in a single line of code? And of course, you don't have to. I mean, usually it's a bad idea to do this. But in this case, it's like a no-brainer. Every advanced coder would prefer this one-liner over this 3-line loop. Okay, so thanks for watching this video and see you in the next video. Bye.